So, like I said, yesterday, I had punched in I kept putting the Y max in the Y min spot. So I just want to go after this one more time. And what we were supposed to find here was when this would be 0.9%, which is 0.009. And I'd want to do a little math here. I don't like all those parentheses. It gets you kind of lost. Now, when you have a problem like this on the test, if you want to solve this by hand, you absolutely could. You know, I am not big on the graphing calculator because I punch stuff in wrong. So we could slap a 1 under here, cross multiply, we'll have decimals and all of that, but we could do it by hand. What they intended for us to do was to say, hey, this is y sub 1. And this is y sub 2. And just use parentheses on the top and the bottom and plug it in. And because people were gone yesterday and they were going to have trouble because I had used the television for the calculator, I'm going to use the fancy one on here, and you're going to use your graphing calculator. So let's go into y equals and put our 0.009 in there, and it didn't take it. Come on. Well, maybe I won't be able to use this one today. Let me try it. Nope. Nothing. Well, I'll have to start this back up. Get there. 0 point. It still won't work. Let's try that. There it goes. Thanks, Shelby. Oh, I said that too early. It's being ornery again. Okay. Shh. Happy birthday, Bill. All right, everybody. No, all right. Everybody have that part set? Now it's window. Do you remember from yesterday, are milliliters really big or really small? So we need lots of them. So like 0 to 500 milliliters is like an eyedropper full of liquid. That's all it is. But we need to see 0.009, which is really, really small. So like I said yesterday, you could try 1, but you're probably not going to see everything you want to see. We'll hit graph because it's just too teeny. Look at it way down there. So we go back and we say, well, 1 didn't work. Let's try 0.1. And try that. Now we can see a little bit. Probably enough for Blinky to help us out. But it's still pretty squished down there at the bottom. So maybe we'll put 1 more 0 in front of there. 0.01. And this is going to be better because we'll be able to see the whole screen. Now, like I said, Blinky could have found us the answer on the other one too, but it's just nicer to see the intersection very, very easily. You need the window back up here? It's right here that makes the difference in the Y max. All right, Blinkster, second trace, number 5, bing, bang, boom, enter 3 times. 275 milliliters. There it is. So, like I said, if you see one of these on the test, you have a choice. The choice is, hey, I could just punch this one in and use Blinky. If you do that, you have to mess around with the window. You have to see exactly what you want to find. If you don't want to mess with Blinky, slap a 1 underneath that 0.009 and just cross multiply and do the math by hand, the algebra by hand. Even though it has decimals, it's actually not that bad for solving. It's just an x. It's not like you're going to have to factor or anything to solve. So totally up to you. Now, that was the one thing I wanted to take a second look at today. And the first thing we had to remember was that we covered inverse variation. It wasn't that long ago, but it sure does seem like it. The beginning of last week. So, suppose that x and y vary inversely. Anybody remember what that looks like? Yeah? What's it look like, Courtney? It is division. I heard somebody say, isn't that division? Y equals k over x. It's the only variation that we studied that has division. So y equals k over x. K is that constant of variation. So it says write a function that models each inverse variation. Describe the graph of the function and then use it. So here's the deal. That means we start with this and we realize we have to find k. That's our job. Well, the only way I can do that is if I know x and y. Ooh, good news. There they are right there. So 2 equals k over 3. Well, I need k. What do? Multiply both sides by 3. So that means k is 6. Now that gives us our new formula, y equals 6 over x. Now, it says describe the graph of the function. What's that going to be called? If we graph that, you know how when we graphed lines, we graphed linear functions. They were called lines when we graphed them. When we graphed quadratics, it was called a parabola. What would this be called when we graphed it? Hyperbola. This is a hyperbola. And then it says use your formula. Find y when x equals 10. Okay. Y equals 6/10. Well, we could reduce that to 3/5. Or we could actually punch it in and put it as a decimal 0.6. 6/10 is 0.6. And that's because with variation, usually there's a real life word problem that's going along with it. We do that a lot, make the decimals. Alrighty, so 2 should be much easier. You should be able to help me out more with this one, right? So what do? Put them in. So what's k? -4. So y equals -4 over x. There's part 1. Part 1 was write a function that models that inverse variation. Describe it. It's a hyperbola. Now, if we wanted to go a little further, for number 1, we could have said it's a hyperbola in the first and third quadrant. Where would this one be? Second and fourth, because it has a negative, but hyperbola is good enough. And then what do we need to do? Find y when x equals 10. What's that reduced to? -2/5. So 3 parts to these. Find k, so you can write it. Then they're hyperbolic. They're going to be hyperbolas. And then go ahead and use your formula. Now, inverse variation wasn't the only variation we learned in that first section, but it's the only one that used division. Everything else was multiplication. So 3 says, when x equals 4, and y equals 5, and z equals 8. Oh my goodness, that's a lot of variables. Write the function that models the following relationship. Z varies directly with x. Okay, z varies. What does directly mean? Is that multiply or divide? Multiply. And inversely with y, what's inversely? Division, the only one where we divide. Well, how are we supposed to find k? Okay, plug all the numbers in they gave us, exactly. So z was an 8, y was a 5 and x was a 4. So basically this says 8 equals 4/5 k. What would you do to solve k? Multiply by 5/4. Yep, multiply by the reciprocal. Well, that'll give us 40/4, which is 10. Cool. Done. Move on to the next problem. No. What did we find that for?
Okay.
Exactly. So go back to the beginning and say, aha, now I know what that is. Z equals 10x over y. Did this one have a follow-up question? Nope. Nope. Just done. We wrote a function that modeled the following relationships, and there it is. Z equals 10x over y. So 43210 me on how's the memory doing here with the direct, inverse, and joint rate. Probably for some of you a good thing we're going to do 3 days a week, right? Yeah. What's the only one that you divide? Just remember that. What's the only one where you divide? Inversely. Everything else is multiplication. If you can remember that, you'll be okay. Alrighty, let's see what the next group of problems is from 8-2. Alrighty, write an equation for the translation of y equals 4 over x. Okay, so they've already started us off. That has these for asymptotes. I wonder if this would be helpful. You remember that? Y equals a over x minus h plus k. So to translate, all we have to do is figure out what should go in for h and what should go in for k. All right. So they're telling us use a 4. What's supposed to go in for h? 0. Yeah, this is the h value right here because remember those asymptotes came from h and k. Well, x minus 0 is just x. So that's not going to do anything. So what do we do with that y equals 3? Put a plus 3 in the back. This graph is not translated right or left because x was 0 and it's not going anywhere. But it did need to go up 3 since y equals 3 is the horizontal asymptote. So now let's look at number 15. Still going to put the 4 on the top. That's what they said to use. Y equals 4 over x. What's going to go on the bottom? X plus 2, exactly. Because it would be x minus a negative 2. It's going to be x plus 2. And is there a number for the back all by itself? Yep. There it is. So basically for these problems, you're just putting h and k back in. That's all you're doing from section 8-2. 43210 me on putting the h and k back in. The asymptotes. How are you feeling? You see the numbers. Alright, so it looks like some of you just have to memorize that formula, and I think you'll feel a lot better about it. A over x minus h plus k. Now, for the wonderful last section that we have been talking about now for 2 days. Look at that little bugger. That doesn't look scary. X plus 1 over x minus 2. Well, anything going to cancel? Don't have any holes. We do have a vertical asymptote. Where is it? X equals 2. And since we're talking asymptotes, let's talk about the horizontal asymptote. That has to do with the degree. So if there's no powers up there, what are the powers? What do we do when the degree of the top is the same as the degree of the bottom? The fraction thing. There's no numbers in front of them. Y equals 1. I would stop and I would go over here right away and put those on. And then say to myself, self, I need stuff that's actually on the graph. That was the stuff that's not going to be used. I need the stuff that's on the graph. Well, that would be the x-intercept. How do you find the x-intercept? Ooh, you better grab your little yellow cheat sheet. Won't be able to use it for the test, but it's good for you right now to have to look it up. How do you find the x-intercept? 0 what? Top, bottom, where? Top. Remember, the asymptotes come from the bottom. That's where the asymptotes come from. Now, just remember this. You can't divide by 0. That's why we have those asymptotes. Can you have a 0 on the top? Absolutely, you can get a 0 on the top. At -1, 0. Now, the y-intercept. Remember, they're always opposites. For the x-intercept, the y has to come out to be 0. For the y-intercept, the x has to be 0. How you get -1/2? What are you doing? These would be gone. -1/2. So now we have 2 nice points on a graph. So -1, 0. And 0, -1/2. Now, that would actually be enough for this branch. But we got nothing for the other branch. Well, we do know it's got to be 3 something and 4 something. You could punch this one in and use the table feature, or you can go ahead and just put 3 and 4. I mean, this is not a tough fraction that we're looking at here, so you might just want to do it by hand. 3 plus 1 is 4. 3 minus 2 is 1. 4 divided by 1 is 4. Put a 4 in. 4 plus 1 is 5. 4 minus 2 is 2. 5 halves are 2 1/2. So 3, 4. And 4, 2 1/2. Definitely enough. You have to make it look like it's going to approach the asymptotes. It's not quite going to get there. And we're not taking your calculators away from you for this test. So if you wanted to check, you punch it in and you see, does it really do this stuff? So parentheses x plus 1 divided by parentheses x minus 2. Zoom 6. Looks like what we have. So always a good idea. Check it with the graphing calculator. Make sure things are going well. All right. Let's see what they've got for us here. That has a little more meat on its bones right there. Factor? How? Plus 3 and minus 3? Oh! What does that give us? A whole at x equals -3. Now, if we want to know exactly where that hole is going to be, here's what we do. We actually cancel this out, and we put a -3 in there, and we see what we get. So -3 minus 3 would be at -6. So -3, -6 is where our hole is going to be at. We wouldn't have to do that. We just have to make sure we put a hole at x equals -3 on our graph. Well, if that was a hole, do we have any vertical asymptotes? None. Because this was the only 0 of the denominator we had, so we're not getting any of those. All right. How about horizontal asymptotes? The degree of the top is 2. The degree of the bottom, 1. 0. If the degree of the top is less than the degree of the bottom, it's y equals 0. That's not 0. If the degree of the top is equal to the degree of the bottom, then we use the fraction thing. It's not equal. If the degree of the top is greater than the degree of the bottom, we don't get one. Well, what are we supposed to put on there? Well, we can always put the whole at -3, -6. 1, 2, 3, 1, 2, 3, 4, 5. There! There's going to be a hole in our graph right there. Well, let's try and find x-intercepts and y-intercepts. Maybe that'll help us out. X-intercept something 0. Where do you get the x-intercept again? Top is 0. When is the top going to be 0? Yeah. Remember, this is where the hole is, so we can't use that one. So 3, 0. Y-intercept 0 something. What's the something? -3. Yep, these x's will be gone. It'll be -9 divided by -3. Oh, we've got a couple points that are on our graph. 3, 0. And 0, -3. That's all we get. So this one, we just have to punch it in carefully and make sure that things are working out nice. We could make a table by hand too, but that wouldn't be bad. But make sure you use parentheses on the top and the bottom. And the graphing calculator is not going to show us that hole. It won't. It doesn't know any better. It's going to try to connect everything up. Well, look at that. It looks like a line. It is. It's a line with a hole in it. That's what it is. So we have to remember at some point to put that hole in this graph. And yeah, there'll probably be a table on the test, so you can just pop a few numbers up on the table. -6, -9, 0, -3, maybe one positive number. Oops, wrong way. 4, 1. So you have 3 points showing. This would be a line with a hole in it. That's what's going to happen with this one. Kind of weird. We've had a hole in the homework, but we didn't really have a good example with a hole. All right, 29. Check the time here. Ooh, we're not going to be able to do 29. You know what? It's okay because we did one like that yesterday. So, yeah. We can start with that tomorrow, right?
Yeah.
No, that's not your homework.
I'm a working man. That's
Well, what are you doing that for? This is supposed to be your job. Learning. Learning's your job.
Night shift.
I'm ignoring you, Courtney.
Graveyard shift. Shut up. I got time for this. You better give some X. It's weird. Yeah, bro. What do you bet? What do you bet? $9. $59.50. Yeah, bro.